How do animals navigate migrations across thousands of kilometers? Chapter 1. The Hidden Compasses. At first light on a June morning in Iceland, an Arctic tern lifts into the cool air, a sliver of silver against the pale sky. Her wing beats are rapid, thrumming like an eager heart. From this basalt island, she will stitch a thread across the planet North Atlantic, Benguela Current, Roaring Forties, to Antarctica and back again. She has never seen the whole world. No teacher flutters ahead. And yet, she goes. By the time the season turns, she will have traced tens of thousands of kilometers as casually as a pilgrim might cross a field. The mystery of migration is not that creatures move, it is that they move with purpose. Across an ocean of blankness, in the dark, in storms, under veils of cloud and dust, over mountains and deserts, year after year, to destinations they cannot possibly remember in the ordinary human sense. The core question, how, tugged at sailors and shepherds long before it troubled laboratories. It turns out the answer is less a single compass than an orchestra of them, a suite of inner instruments tuned to the world's grandest, quietest signals: celestial light and magnetism, smell and sound, sweeping winds and tiny waves, the clock in a feather and the map in a bone. Imagine the earth as it is, a humming globe beneath invisible lines, the geomagnetic field arcing from pole to pole. Above, sunlight filters through the atmosphere, scattering blue, polarizing, striking dust and water vapor, revealing angles to the careful eye. The sky shifts like a clockwork, sun rising and setting, stars wheeling in circles around a fixed point. Oceans carry whispers of continents in their salts and smells. Rivers remember mountains with traces of stone. The planet is a library of signals, and animals are its most devoted readers. Start with the sun. If you step outside at noon and close your eyes, you can sense the sun's warmth on your face, but you cannot tell its true angle any better than a guess. A pigeon or a butterfly does this differently. They hold in their bodies an internal clock, circadian rhythms entrained by a patch of morning light, a nerve's quiver at dusk. With that clock, the sun becomes not just a light source, but a vector. If the sun is here and my clock says noon, then home lies there. This sun compass is a living computation performed in flight. Starlings and thrushes do it across continents. Hawks over thermal fields. The monarch butterfly does it lofted by autumn wind, tacking southwest toward a Mexican forest it has never seen. As clouds sweep over the day, many species use polarized light, a geometric fingerprint laid across the sky at sunrise and sunset to keep their bearings when the sun itself is hidden. To the human eye, the sky seems uniformly bright. To a bee or a bird, it is crossed by faint, reliable patterns of lines. At night, there is the stellar compass. In late summer, a garden's shadow might hold a secret theater. A young warbler, restless, hops in place, jostling toward the direction it will soon take under the cloak of darkness. When scientists placed songbirds under a dome painted with stars, the birds chose their outbound direction only when the simulated night sky rotated properly around a single point. The map in their minds is not a chart of individual constellations, but a recognition of rotation around the northern sky's still center. The motion this wheel of lights is what tells them where north lies. It is, in a sense, time carved into pattern. In the field, these birds lift at dusk and slide south along rivers and ridges, threading through the continents on tracks older than cities. But skies can be fooled. Clouds erase them, the day shortens. So life evolved a deeper instrument, a magnet inside the mind. The Earth's magnetic field is faint, about as strong as a fridge magnet spread across a planet, but animals can feel it. They do not sense it as we sense light, with bright drama, but as a quiet orientation, a nudge. In salmon, magnetism is stitched into their first oceanic forays, imprinting field signatures like pages in a logbook. When the field strength and angle match those logged values, the fish know roughly where they are on the planet and which way to turn. In turtles, the embryo whispers this field into early nerves. Hatchlings, facing a black Atlantic, do not panic. They paddle diagonally to the waves, cross the rip's tug, and orient by field inclination and intensity. In some birds, the magnet sense may be partly chemical proteins in the eye, whose reactions flicker in response to field lines, and partly physical crystals of magnetite that tug on neural tissue like a microscopic compass needle. However it is built, the sense bestows a subtle map, grid over the Earth, not as precise as coordinates, but good enough to push a life in the proper direction. Smell maps are the least obvious and perhaps the most beautiful. Consider a homing pigeon. Released hundreds of kilometers away, it circles and then sets off in a line. How? Air is not empty, it carries the breath of landscapes, the tang of seaweed and the resin of hills, the mineral signature of far-off dust. Pigeons, salmon, some seabirds, even eels, are connoisseurs of these vapors. In rivers, juvenile salmon memorize the scent of their natal stream, a tincture of rock and moss, insect and pine, and years later, fat with ocean, they find that recipe in the chaos of a river mouth and swim up it like someone following the smell of bread to a kitchen door. Along coasts, certain birds read vast odor landscapes, the bloom of plankton, the spices of land moving between feeding grounds in a dance of smells as sure as any line on a chart. These maps of scent blur, of course, storms scramble odors, currents tangle them, yet even in churned waters, enough of the signature remains to point home. There are more instruments. Sound below our hearing is a guide. The low sighing of surf wraps around islands and continents. Whales sing and feel ridges with sonar. The boom of breaking waves tells a fledgling petrel which horizon hides the sea. On land, wildebeest do not carry compasses, but their senses weigh the wind and the promise of rain petrichor rising from baked earth and move in arcs that match the continent's breath. A herder in the Serengeti could tell you, the herds follow the grass, but to follow grass, you must first follow water, and to find water, you must trust clouds and wind and the tilt of season. Migration is a choreography between inner hunger and outer signal. The hoofprints on the plain are decisions every hour. Layer these compasses together and you get resilience. A bird under overcast sky leans more on magnetism. A turtle lost in conflicting cues waits for a wave crest and reads the wave's approach. The dragons of hydrodynamics under the skin tell it where the open ocean lies. A butterfly's sun compass falters under haze. It adjusts to wind and landmarks, to rivers that always flow downhill. Animals do not insist on one sense, they negotiate. The world is noisy, redundancy is survival. To witness the negotiation, follow a bar-tailed godwit leaving Alaska in autumn. She weighs barely more than your cell phone. Her body is efficient as a glider, but powered by fuel, fat layered beneath feathers. Before departure, she balloons on insects, doubling her weight. Then she lifts and does not stop. There are no islands, no feeders, no stepping stones. She flies 8 or 9 days, a bow drawn taut by the North Pacific's winds, to New Zealand. At these heights, the sky is less a canvas than a machine. Jet streams coil like ropes, Fronts breathe, storms shear air into invisible ramps. The godwit is not a passive leaf, but a reader who chooses. She climbs into tailwinds when they sing from behind, drops lower when crosswinds threaten to drift her too far east. Her magnet sense gives a long-axis reference. The sun by day and stars by night refine her heading. Her inner clock keeps the computations honest. She arrives lean as a spent flame and steps into shallow water as if she has merely hopped across a puddle. The godwit is a virtuoso of distance. The monarch is a virtuoso of inheritance. Monarch butterflies in North America travel south each autumn, some from Canada toward a few mountaintops in central Mexico. No individual has taken the trip before. It is their great-grandparents who knew the way. And still they go, using the sun compass keyed to their circadian clock, calibrated by certain wavelengths in the sky, cued by temperature to enter the torpor of winter. They spiral among firs, their wings a sound like late rain. In spring, they fly north, lay eggs, and die. Their children continue, and so on, a relay of lifetimes. The map, so to speak, resides not in memory, but in the marvelous specificity of genes and physiology. A program sculpted by selection that turns sunlight and temperature into direction and timing. Timing is half the journey. What looks like a single decision go is actually a braided calendar. Day length wanes, hormones change, fat stores shift, muscles prime. In the ocean, eel larvae ride currents set in motion months ago by winds blowing over distant seas. On the tundra, caribou watch the angle of the sun and the taste of the wind. If they leave too soon, calves drop on snow. Too late, the flies and heat will bleed them dry, and the rivers will be too swollen to ford. The how of navigation is inseparable from the when. An internal clock marks day. Another, more ancient clock, marks the year. The circannual rhythm, kept by changes in daylight and melatonin, by temperature and resource cues, sets the stage for every compass. Of course, the earth changes. The same instruments that once sufficed can lead astray when the score shifts too fast. Light at night, cities, rigs, ships, scrambles the star compass, lures birds into windows and rigs, spins turtles toward parking lots rather than horizons. Noise drowns out the low song of coasts. Chemical signatures in rivers warp under pollution. Salmon, at a fork of sense, must choose between wrong kitchens. Magnetic fields wobble as they have always done, but now power lines and devices lace the world with local hums. Winds reweave under a warming climate. The old currents migrate north. In this volatility, animals do what they have always done: negotiate, adjust, try again. But some negotiations fail. The orchestra can go out of tune. Yet the resilience persists. Migration is not blind fate, it is chance sharpened by feedback. A young stork might launch on a line an elder would never choose. If it survives, if it finds a winter that is mild and food enough, it may return earlier and breed, and the population's map bends. In some seas, whales relearn feeding routes after maelstroms of whaling, teaching calves with bodies as well as with songs. Culture information passed not by genes, but by living side-by-side layers onto compasses. Tools are born. In the Rift Valley, a matriarch leads her elephants toward hills that hold memories of rain in their stones. The calves imprint not only the hills, but the timing, the pace, the pause at a safe river crossing. What is navigation, after all, if not knowledge moving through bodies? Return to the tern. She is small, the world is large, but she carries the world in her like a memory of a dream she has never had. The daily wheel of the sun, The circled stars, the tilt of the planet's force field, the smell of the sea under certain clouds, the dip and drift of winds along a continental edge. In her, these are not facts but feelings scalar and soft. She is not calculating with numbers. She is listening with cells. She is not following a line on a map. She is following the planet itself, which is the original map, the sun and night and rock and brine and invisible thread of magnet, the undulant body of air, the footfall memory of hoof and paw. On a coral beach in the dark, a turtle chooses a horizon by the faintest brightness, slides into foam, and finds the open ocean by rising on a swell and feeling the waves push. In a fog, a thrush flies by magnet and by the taste of air. Over the Sahara, a honey buzzard rides a sky river it cannot see. Down a river turned cold, a salmon turns toward a childhood scent stored in its nose like a blessing. The planet spins, the orchestra plays, they go. The first chapter of this journey, the one you are reading, has outlined the instruments, sun and star compasses tuned by inner clocks, polarized light patterns, a magnet sense woven from physics and chemistry, smellscapes and soundscapes, the language of wind, water, and wave, redundancies and negotiations. These are not gadgets but evolutions, fine and fallible, robust and improvisational. Together they answer the first half of our question: how do animals navigate migrations across thousands of kilometers? By carrying within themselves working models of the world and the time that unfurls it. But a map and compass, no matter how exquisite, are only part of the story. The rest is learning and lineage, memory and mentorship, risk and ingenuity, the living calculus of choosing routes that feed rather than starve, that avoid the hail of talons and the wall of glass. In the next chapter, we will walk the routes themselves, from savanna to sea, from desert to cloud lines, into the collective knowledge of herds and flocks and pods, the fragile inheritance of stopover wetlands and flyways, the future of these living rivers in a warming, brightening, louder world. For now, as evening leans over the Arctic and the tern tilts her wings toward distance, we can stand quiet under the first stars and feel the Earth's faint magnetic breath in our own chests, an echo of a compass older than thought. Chapter 2. The roads in the air, the rivers in the sea. At dawn over the Serengeti, the wind smells of dust and sun-warmed grass. Wildebeest begin to move, first a ripple, then a heaving current of bodies drawn by something that is not a voice but a chorus. The taste of fresh shoots in the air, the far glint of thunderheads, the memory of where water held in the bones of the elders. The migration arc looks simple on a map, a loop penciled over Tanzania and Kenya. On the ground, it is a negotiation renewed every day. Hooves test the earth. Heads lift to test the wind. Calves stumble forward, learning with each step that a road is not always a line, but often a band, a braided corridor with branches and cul-de-sacs. The navigation instruments inside each animal, the clocks and compasses, are necessary. The route itself is a shared story. Inheritance in migration can be genetic or cultural, sometimes both. A monarch butterfly inherits a physiological sun compass program and hormone schedule timed to milkweed and cold. A humpback calf inherits something else. The road taught by its mother, the taste of krill-rich waters near a bank known to its clan, the timing to leave tropical calving grounds for higher latitude feeding. If you could see the sea's roads, you would see ribbons of memory brushed by flukes and songs. Humpbacks, through their cultural exchange, sometimes alter songs across entire ocean basins, a spreading wave of melody, but they also share feeding tricks and routes. The calf, nestled in the lee of its mother's body, is shielded from drag, learning the texture of current around seamounts that interrupt the flow, learning how to read the sea's faint alphabet of temperature and nutrients. This is navigation as apprenticeship. Not all learning is maternal. In cranes, family groups fly with elders who know where safe stopovers lie and which rice fields aren't riddled with shot. In geese, adolescents make their first outbound journey beside experienced birds who have survived the demands of wind and altitude. Consider a bar-headed goose. It rises among the lakes of Central Asia and flies across the Himalayas, over passes taller than the highest thunderheads, where oxygen is thin enough to make metal breathless. The goose times its climb to a passing window of weather, its blood primed to bind more oxygen, its heart a steady piston. It uses the wind's geometry. At certain hours, valley winds lift, mountain shadows calm, and a pathway opens in the air like a temporary mountain road. Young birds learn the cadence of these windows by traveling with those who already know. On future flights, those cadences become as much a compass as the sun. On long journeys, stopovers are as critical as direction. A shorebird does not simply aim at a continent, it aims at a chain of beads: marsh, estuary, tidal flat, bay. Each bead is a refueling station where the invisible math between fat reserves and distance is recalculated. The Pacific Flyway, the East Asian Australasian Flyway, the Atlantic Flyway, these are not abstract names, but living highways stitched to places like the Yellow Sea's mudflats, Delaware Bay's horseshoe crab beaches, the Banc d'Arguen's tidal prairies. A red knot leaves Tierra del Fuego and ascends the Atlantic like a music scale, pausing to gorge on crab eggs timed to spring tides, then lifting again. It arrives in the Arctic barely heavier than a fist, its inner clock and the sun's angle telling it that insects will now explode from the tundra and chicks must hatch into the brief feast. Detours are part of the craft. A bird thrown off course by wind uses what researchers call drift compensation. It senses the accumulating sideways push through magnet cues, sun angle, star pattern, or even by landmarks if it flies low enough, and corrects over time. This correction might not be immediate. Over the open ocean, with few landmarks, the bird may keep an average heading that, combined with shifting winds, yields the desired destination. The godwit crossing the Pacific performs this art at a high level. It climbs or descends to different altitudes to find favorable tailwinds, treating the atmosphere as a layered river with slower or faster currents. It's not thinking in symbols. It is feeling, comparing, adjusting. Sometimes the map is a gradient, not a path. The European eel, born in the Sargasso Sea among gyres framed by currents, drifts as a larva toward the coasts of Europe and North Africa. As a glass eel, it tastes the cocktail of coastal waters and pushes inland, slipping up estuaries, into rivers shaded by willows or flowing under ancient stone bridges. Years later, adult eels will leave their inland quiet and return to the Sargasso to spawn, guided by a suite of cues still being unraveled: magnetism, currents, perhaps minute temperature and chemical gradients that whisper of a place they have never visited as adults. They do not hold a route in mind like we hold a street plan. They climb and descend invisible hills of sensation until the hilltop that is home rises beneath them. In the Arctic, caribou draw thin lines over snow and tundra, their hooves splaying to cross marsh and muskeg. They travel to outrun insects, to find lichen under snow at the right time, to calve on windswept ridges safe from wolves. The timing is everything. Leave too soon, and snowpack hides food. Leave too late, and rivers flood calves off their feet. The compasses are tuned to this schedule, Day length at high latitudes changes fast. The angle of the sun swings dramatically, turning circadian feedback into a sharp, seasonal drumbeat. Herds navigate as crowds do. Information flows through bodies. One cow senses a change in wind that hints at a storm. Her small deflection ripples through neighbors, and soon the herd's line bends. This is not telepathy. It is the physics of group movement, colored by individual experience. In a crowd of pathfinders and followers, the average of many imperfect compasses can be more reliable than any single one. Big migrations often begin with small decisions. Imagine a piccolo of a bat lislers or straw-colored leaving its roost at dusk. Bats migrate too, some across surprising distances, their maps traced on rivers of insects and flowers. They feel wind with wing membranes alive to the smallest eddy. They hear the world in echoes, so that the texture of a forest edge is like a signature. As seasons shift, their foraging grounds empty or fill. A bat does not consult a calendar. It feels the change in its belly and the fading of floral scents and the hush of mosquitoes dying off. The first few nights it moves farther. Soon distance accumulates into migration. All these roads, airborne, underwater, overland, are built on a truth both subtle and grand. The animal's map is multi-layered and probabilistic. A bird can use a magnetic map of the planet's broad latitudinal and longitudinal gradients, encoded in field inclination and intensity, to get into the right neighborhood. Once there, smell and landmarks take over. A salmon, on finding the right coastline via a magnetic cue, switches to a smell map to find the one river mouth whose recipe it memorized as a smolt. A turtle, on leaving its natal beach, uses wave direction and magnet fields to reach distant gyres where food floats. Years later, as a subadult, it will use a different balance of cues. Navigation is state-dependent. Body condition, age, and experience change, which compass gets the loudest say. Experience can remake routes in a single generation. White storks from certain parts of Europe once wintered exclusively in sub-Saharan Africa. Over decades, some began to winter on landfills in Spain and Portugal, attracted by reliable food. Young storks following elders learned a new habit. The new wintering grounds shortened migration, reduced risks for some, and altered the flyways culture. This is how migrations evolve in real time, not just through slow genetic change, but through the flexible memory of groups. The new route may be a boon until the landfill closes, or until a drought shifts the advantage back to Africa. In such moments, the ability to read primary cues, the sun, the wind, the taste of weather, matters more than a static tradition. If the inner instruments provide direction, the outer world provides the gates. Winds carve seasonal corridors into the troposphere. Currents sketch invisible roads into the sea. Animals wait at these gates. Swifts roaming European skies feed for months on insects aloft. Then, when a favorable pressure system sets up, they pour south on tailwinds, crossing the Sahara not as a line of ants, but as a cloud of scythes. Dragonflies globe skimmers, with wings like stained glass, ride monsoon winds from India to East Africa and back across generations, their multi-stage migration interlaced with the forward march of rains. They are tiny and seemingly fragile, yet their road is tied to the largest climate engine on Earth. The compass in their bodies is built to interrogate this engine. Light cues a change, wind confirms it, humidity seals the decision. Energy budgets decide what is possible. Every gram of fat is distance or a cushion against weather. Before departure, bar-tailed godwits retool their bodies. Flight muscles bulk, digestive organs temporarily shrink to lighten the load. The heart and lungs adjust. In midair, they drink their own reserves, water liberated from fat oxidation, keeping them hydrated over salt deserts. They sleep in micro-sleeps, seconds that add up to rest without falling from the sky. Their strategy is a physiological arc bent around physics. In a stronger headwind than expected, the decision tree is stark: climb into different air, turn to a known island, or perish. Their senses feed this tree constantly. Every hour the map is redrawn by new winds. The why of a course change is not known by the bird in any conscious way. It is felt as a need and satisfied by action. Predators and parasites write their own lines into these stories. Raptor migration bottlenecks, places like Israel's Hula Valley, Panama's narrow isthmus, Spain's Strait of Gibraltar, are choke points where uplift and geography compress the rivers of birds. Falcons and eagles know this. Their presence pressures weaker or less experienced migrants to fly earlier, later, higher, or along alternative paths. That pressure can split a flyway over decades, creating twin lanes where once there was one. Even fleas and ticks, the micro-predators, can shift timing. Herds alter their calendar to minimize the weeks when insects are worst, pushing departures earlier or later, and thereby changing who meets whom at a river crossing. If this seems like a fragile dance, that is because it is. But fragility is not the same as weakness. It is sensitivity, and sensitivity can be an engine of adaptation. When the Sahara expands years faster than wildflowers can march north, some birds arrive to find a changed barrier. They may skirt west nearer the ocean, where cooler air births more stable thermals. When rivers are dammed, salmon face a broken ladder. Some populations learn to linger in estuaries and feed. Others try to climb fish ladders built by human hands, and still others fade. When nights brighten with cities, nocturnal migrants are drawn into fatal confusion. Yet in places where lights are dimmed during peak migration, the stars return to the dome, and birds pass again with fewer collisions. The map and the world negotiate, sometimes with mercy, often without. There is a temptation to project human tools onto these travelers. We ask, do whales have GPS? Do birds carry maps in the way we keep maps in our phones? The truth is both more humble and more wondrous. A whale does not know latitude and longitude as numbers, but it may read the bend of temperature fronts, a line where cold and warm water meet, as if it were a coastline, and follow it like a road. A bird does not see magnetic field lines as arrows, but experiences them as a bias in a receptor's flicker, integrated by the brain into a sense of northness. These are analog systems in a digital age, exquisitely tuned to a world of gradients, and yet our tools can join theirs. In conservation science, satellites trace tracks across seas and deserts, tiny transmitters riding on backs like lanterns. The cartridges of data they return let us watch a single curlew fly from Ireland to Western Africa and back along opposite shores. A turtle cross currents whose names once belonged only to sailors, a stork loop around a storm, and tack like a skiff. We see where stopovers are most vital, which forests draw herds year after year, where light pollution is deadliest, which trawler fleets are intersecting whale highways. We see routes splitting with climate, breeding grounds creeping poleward, migration windows shifting earlier each decade. The map grows alive, and with it, our obligation. Obligation rests not only on wonder, but on reciprocity. We have, after all, been guided by animals for as long as we have been human. Hunters read caribou paths to find rivers. Fishermen watched terns to find shoals. Sailors watched whale blows to read weather. Our own migrations, the movement of stories across mountains, of languages along coasts, of seeds and songs and ideas have been braided with non-human roads since before writing. The compass in us is different, but the yearning is similar. To go where the seasons promise, to return to what nourishes, to carry knowledge forward. If we want these roads to persist, we must repair and protect their beads and bridges. Some solutions are humble. On coasts, shielding lights or switching wavelengths can return the night to turtles and seabirds. On towers, changing steady red lights to blinking ones prevents fatal attraction for migrants without sacrificing aviation safety. In cities, lights-out programs during peak migration weeks remove the trap of glass and glow. Rooftop gardens and night-skimming beams turned off open a path back to the stars. Rivers can be reopened to salmon with ladder design that respects flow and fish behavior. Obsolete dams can be removed to let smell maps be readable again. In agriculture, leaving stubble in fields during critical stopover weeks feeds cranes without undue loss. Shallow wetlands can be pulsed with water to mimic historical floods, providing red knots in godwit staging areas. At sea, dynamic management closing certain zones when whales are present based on real-time acoustic monitoring lets ships and giants share the ocean with fewer collisions. The largest solutions are acts of patience, protecting chains of habitat that are only valuable in concert. A single estuary is a jewel. 3 estuaries spaced just so along a flyway are a lifeline. A meadow alone is a painting. A meadow aligned with a mountain pass and a sheltered valley is a route. Conservation in a migratory world is cartography plus empathy. It is thinking in corridors, in seasons, in the quality of gates. It is honoring the unseen, the smell recipe in a river that salmon need, the low song of surf that petrels use, the invisible polarizing pattern at dusk that a monarch reads like scripture. Even as we help, we can learn. Long before a weather model forecasts a late spring, returning swallows hesitate at the edge of cold. Before a satellite detects a change in sea surface height, humpbacks arc toward richer margins. Their bodies are arrays of sensors, updated daily, that integrate data we barely perceive. In watching them, we can refine our own models, make better decisions about when to plant or fish, how to design turbines and power lines that hum less or break lines of flight less. This is not to romanticize animals as oracles, but to acknowledge them as co-readers of the planet, a readership worth studying. The deeper story in all of this is that migration is not an exception to ordinary life. It is ordinary life at scale. The same rule that guides a foraging ant to take a straighter path when the scent is stronger also guides a sea turtle to stay on course when the magnetic signature matches a remembered value. The same feedback that steers a human walking home by the smell of basil steers a pigeon home by the smell of hills. We, too, are gradient followers. We, too, integrate cues unconsciously. Migration is a mirror that shows us our own embodied intelligence, stretched across weeks and continents. Return one more time to the Arctic tern. Months have passed since she left Iceland. She has skimmed waves that flashed with moonlight and slid under skies where albatrosses draw infinity symbols. She has threaded storms by feeling their shoulders and let trade winds carry her like a canoe. In Antarctica's summer she fed in cold waters bright with plankton, listened to the low conversation of ice and swell, and banked fat for the journey north. Now, as the Southern Ocean prepares its winter, she turns again. She has no calendar to put on a wall. She has something better, the day's arc shortening, the food's distribution shifting, the weight under her sternum changing as fat is stored. the magnetic contours under her path, rolling like a familiar lullaby. She chooses a route, the one favored this year by the wind, and goes. Her mind holds no map in ink, but her body remembers the world. Parallel to her path, in the central United States, sandhill cranes gather on the Platte River, standing ice blue in morning fog, calling with voices like carved wood. They have flown down from Canada and Alaska and Siberia, funneling into a bottleneck that is both old and freshly imperiled. The river is narrower than it was a century ago. The roosting bars they prefer are rarer, yet the cranes still come, still dance, still teach their colts to leap. They will lift again, spread across western fields and northern marshes, each family threading a route that their elders show them. The trajectory of a single crane is a line of decisions cradled in song. We have asked at the start how animals navigate migrations across thousands of kilometers. The answer is a tapestry. Inner instruments, sun and star compasses calibrated by clocks, magnetic senses in eyes or ears or crystals, smellscapes and soundscapes, wave reading and wind reading woven together with learning, from mothers and matriarchs, from peers and pathfinders, from failures, from storms survived, from hunger and comfort. It is also a story of landscapes and seascapes that host these instruments, winds that open and close gates, currents that braid oceans, rivers that keep their recipes if we let them, nights that keep their darkness if we dim them. To stand beneath a midnight sky in autumn and hear the seep calls of migrating thrushes is to hear the planet speaking to itself across species. To watch a line of elephants vanish into a heat haze heading toward kopjes that know how to hold rain is to witness memory moving bodily over stone. To see a turtle's track from nest to sea is to see the first paragraph of a journey written in wet sand. None of these travelers believes in destiny. They believe in cues. They are practical, they are improvisers, they are conservative when they must be, and bold when they can afford it. In the years ahead, the roads of air and sea and land will shift. The monsoon will come on different days. The jet stream will meander in new curves. Deserts will pulse on new beats. Cities will blaze brighter or, with luck, less so. The orchestra will have to retune. Some species will lose their place in the score. Others will find new harmonies. If we keep faith with the planet, protecting corridors, honoring nights, cleaning rivers, letting coasts breathe, then the ancient intelligence in these journeys will have room to do its work. The compasses will still point, the clocks will still tick, and bodies will still translate the world into motion. Picture, finally, a child standing on a seawall at dusk, pointing up at a craned V crossing the moon. The child asks, "Where are they going?" The answer is both simple and very long. They are going to where water and grass are waiting. They are going to the place their mothers showed them. They are going to the slope in magnetism that feels like home. They are going where the wind this morning said to go. They are going where the world calls them, and they are answering by being exactly what they are, instruments of the earth, reading by touch and taste and time, carrying road and destination within the same beating heart.